inches out. As we start getting past fiber cement, we have to start changing our structural attachment. But we have some good testing data from BSC on heavier cladding systems. So actually, Kirk is looking into a screwing pattern for a job that we're actually starting tomorrow, where we're doing the same assembly on a new house, a custom house, but it's got stucco on the outside. So now we're 4 inches out and we're carrying stucco, and so that just has a different connection, fastener and layout back to the house. But just to bring that up, that's doable. Okay, I'm going to move on to interior items. Interior items that we want to cover in terms of logistics of the build, not design of the HVAC system, is mechanicals. So HVAC. So we've talked probably a lot about this in a lot of different meetings, but generally speaking, the challenge with the mechanical system in our industry is that they're not often designed. They're often sort of thumbnailed and guessed. We see a lot of BTU per square footage calculations. We see a lot of people sort of thinking it's about this much, and I know one guy that's got the house-shaped cardboard, and it's depending on how far away it is from them, that's the BTU sizing from the street, and that's just not the way it works. To give you an example, we have 2 different mechanical, highly competent mechanical folks that have ran manual J sizing on these. They were within 3,000 or 4,000 BTUs of each other, but they're still off. And what that tells us is it's not perfect. Nobody knows exactly. There's so many variables and inputs, it just depends on what you put in. We have another contractor working with us who has an HVAC contractor that came back with their calc being 3 times that amount. And so the design is the key to everything, right? If we have a system that is too big or is too small, we're going to have all kinds of performance issues and equipment durability issues. And the mechanical ventilation requirements of this house are very, very different in the fact that we're going to be so tight. Air changes per hour on the last 7 that we did all hit 0.6 almost to a T. And we didn't do anything substantially ridiculous on air sealing details other than this membrane. But we were also only needing about 180 CFM to reach -50, right? And so that's substantial. To note then that when your 150 CFM dryer is on, it's fighting now a 60 Pascal or 50 Pascal force, and so its performance drops because it can't overcome 50 Pascals, and it's not pushing 150 CFM anymore. Right? Same thing with your vent hood. If your vent hood is supposed to flow at 150, but at 150 you're at -50 Pascals, which you in theory wouldn't be because that's 150 CFM of flow at about 0.3 inches of water column, which is about a third of that. You're not going to be moving 150 CFM. So then your collection over your cooktop all of a sudden falls off, right? So when we start running even very small, modest ventilation appliances, we have to provide makeup air to match that, and then that makeup air coming in is more than the load of the loss of the house itself. So we have a whole other furnace just to heat that air coming in. And these are good problems to have because most people just deal with it by throwing 100,000 BTUs of furnace in, and they just cover all of the loss and all of the leakage and everything. So these are really important details, and so what we're going to find is mechanical systems that seem more complicated than we're used to, that are harder to design and understand, and are costing way more, right? But the fact is you can get a $100,000 or 100,000 BTU furnace for about half the cost of a 40,000 BTU furnace, because that's just it's a demand thing, right? We're also running on these houses a different ventilation strategy. We're not running fart fans to all the bathrooms. We're running a central ventilation system with a high-low heat exchange and energy recovery, and we also have the dryer and the cooktop requiring mechanical heated makeup air. And so we now have a makeup air unit. And this is something that isn't in most houses at all, because makeup air is sort of leaked in through building leakage and is diffused through the whole building, as opposed to we're now bringing this air in through a very small opening and trying to dump it somewhere in the house, where when you concentrate makeup air anywhere in the house, if it's cold out, it's going to cause problems. So the design of the system is really important. The understanding of how a mechanical system works is really important, and then making sure we execute. We, generally speaking, like to lay out the ducts, or the system and the ductwork and the registers, so that we have very little need to change framing, if at all. This is one of those situations where we have a layout on the drawing where we want to show the HVAC contractor, this is where you're going to run the ductwork. We don't want them coming out like Pat's story at the beginning and just starting to lay out, you know, where they're going to cut holes for all the boots and then just running ducts wherever. We want the ducts to run where we want them to run, because if they don't, they run the risk of running into something else we need that space for. Okay. Talked about ventilation, plumbing. It's kind of the same thing. We tried to design this house so that we had efficient layout of our vents and our drains and our supplies into a common wet wall with the least amount of sort of runs, and stacking everything so we could just be really clean from the basement up. But that's important for us to pay attention to it, because when they bring in the mechanicals into the basement before we pour the slab, placement of those stub ups become critical, because then we don't have to like jog across and cross over and create. I don't know if everybody was in the room when I had that picture up of the plumbing detail. I probably shut that down, but you have them designing, the plumbers designing PVC sculptures in the wall to try to figure out how to make the drainage work. We've got that all laid out on the plan. We don't want them doing a lot of time thinking, and we don't want the plumbers bidding for the time they normally spend on designing systems. We just want them installing the system we designed. Okay. There's one location in the Cedar where we have plumbing on an exterior wall, and that's in the kitchen. Now, generally what we've done is an island vent. If you're not familiar, is anyone not familiar with an island vent? It's just a vent that comes up and goes back down. But in this case, we have a furred out wall, and we also have that same situation on the Maple, where we have a plumbing vent in the outside wall. And so with a furred out wall, we can just run the vent up into the floor cavity or the attic space. Okay, John?
What's the air exchange rate you guys are designing for then?
0.6. ACH 50?
I mean, as far as, how many air changes per hour are you guys building into your system, or what's the design for that?
Like natural air change?
Yeah.
I don't know what the natural conversion is. Divided by 10?
Yeah.
It's like 0.06.
Yeah. There's very little natural, so it's all coming either through the, and we have a number. It's, on a design day, it's tens of CFM. I mean, it's not much natural. But then anything coming in through the ventilators going through the ERV, HRV system,
So it's
or
balanced.
makeup air.
And then on the HRV or ERV, then what's the exchange rate you guys per hour are setting that at, or what are you guys trying to?
So we got a high-low setup where background's running, I think, at 60.
Between 60 and 80, depending
Yeah.
on which drawing, which plan.
And then you push a timer at one of the high concentration locations
Bathroom with
to
kitchen.
jump to high to like 120, or,
Yeah,
160, somewhere in there.
Depending on how.
and it'll run for 20 minutes at that rate, and then shut down back to the low.
We're a little higher than code minimum for that low rate, because we're exhausting air out of these bathrooms instead of a bath fan, so we have to hit 25 continuous in each bathroom. And then we want to get all continuous in the kitchen area, and we want a little continuous in the basement, so to get that all done, we've got to push it more like 70 or 80.
Just one quick FYI on our Cedar, we are doing the island vent on, even though it's on the exterior wall.
Yeah.
We're just furring out with 2x2s.
Oh yeah, that's right.
Yeah.
That's right.
Yeah.
So just an island right there.
Yep.
Okay. Is there any other comments on plumbing or?
I was just gonna say on the HVAC heating, loads were in the 25,000 BTUs an hour design load,
Yeah,
and for the
22 to 25, sort of that
22,
range.
23, 24, 25, yeah, under 25. And for the cooling, we're at about a ton and a quarter, 15,000, about a ton and a quarter. Ton and a half is gonna be probably where we'll land, just to cover some extra, but we'd like to avoid 1 to 2 ton.
Mhm.
Too big.
And I think, I wanna say 30 or 40% of that cooling loads make up air.
Make a pair and like, and it's heavy laden load.
Yeah.
Water heater is going to be so the water heater, we had to go from most people today would put in a power vented water heater. That uses inside air and that causes some additional negative pressure we don't want to deal with. So we're going to a 2-pipe, typical non-condensing storage water heater as our base model.
Sealed.
Yeah. So it's sealed, it's not taking house air, it's using outside air and venting to the outside. But it's not condensing, we're still at 0.68 or 0.67 humidity factor, I think. So, yeah. We'd like to step up to condensing, I'll another point about that.
I just wanna bring up too, it's 20 to 2, and I wanted to get everybody out of here by 2. So I wanna try to move through the last points as fast as we can, noting and acknowledging that HVAC is extremely complicated and is a whole nother research project, let alone training, let alone industry. But I wanna get through this and then circle back with any last minute questions, and then some other ideas or feedbacks or whatever pieces that we can backfill here in the days and weeks coming to the first build. So on interior items, the electrical, most of you have seen this, but this is a small model detail of how we'll run the base, or how we have run the baseboard. In that we basically fur out with these 2 strips here, 3/4 inch scraps basically. We put a shallow box in here with a mud ring, and then we use a 3/4 inch piece of trim. Gives us a total of 1.5 inch cavity, and then cap it in some way. This is an oak detail from a house that we did back in 2006. Here's what that looks like sort of on the setup. Here's an example of an interior wall framed out to receive a door jamb and a light switch. This, side note, this house, which was actually house 4 in our original pilot research done back in 2006, all the interior walls were thin wall OSB, so that's why we have that detail. There's a front door detail with the frame out closet that's all thin wall. There's the chase before the trimmers get to it. There's a switch detail. If I zoom in, you can kind of see what that sort of that mud ring looks like. So the wall board that covers that obviously will hide the face of that mud ring. More outlet detail here running these chases, and then the other thing to point out here is that what we will spray a water-based primer on all of the OSB prior to drywall. This helps with the mud, so that we can tape rock to OSB, like in the corners and the ceilings. The primer helps us with adhesion and keeps the mud from drying out. Here's a detail of the finish where we have just a painted MDF, trim stock and some sort of stock cap. We've talked a little bit about some other sort of pre-manufactured caps, like a half round doorstop or something like that. This is some, I think, was a site fabricated base shoe, that they just sort of ripped some square stock and knocked down a corner. Here's that detail with it prior to finishing. So on the exterior walls, this detail will be required. Once again, all the interior walls are framed with regular 2x with drywall on both sides, so that all of the electrical chases and everything are the same in there. And then you have a 20-inch truss, open web truss to run all your lighting and ductwork and vertical or horizontal runs.
On the interior perimeter walls, what if someone wants to hang a picture or something on that wall?
They won't need a stud finder.
I thought we were concerned about but we're not concerned about any penetrations into that?
As long as their fastener is less than 2 inches, I mean, that's the key, is they can push in 2 inches into that wall, 2 1/4 inches, they hit a membrane.
Okay.
In fact, in the first homeowners of the first 4 prototypes, we wrapped up a housewarming gift. It was a box of 100-inch-and-a-half screws for picture hanging.
Yeah. Here's some examples, some interior finishes on a trim package. Some other trim details with the windows, because this is a thin wall system, and the windows that we've used historically are made by, so they're marketed and sold at Home Depot on the shelf. They're called American Craftsman, which is owned now by Anderson, and it's their Silver Line sort of edition. But they're a really narrow jamb, okay? And so what that then allows us to do is set the window into what's sort of referred to as an innie. And so then you've got basically 2 1/4 inches of structure, right? But this window jamb on the interior is about 1 7/8 inches, I think it is. Is that handy? Do you remember? Something like that.
Yeah.
Where you end up with a sliver, like a 1/4 inch sliver of a jamb extension into your trim. If you kind of zoom into this detail right there, you can see, well, this is a little bit more. It looks like more like an inch. This is a little jamb extension that gets ripped down. You know, so you've got your stool gets set into that. You know, if you're using this type of detail, there's a little bit of a fancier trim package, but you know, you can set your stool in all the way down, put an apron in your side and head casing in, and then just jamb extension that out. If you're doing just a typical picture frame setup, you still got to run a jamb extension around, and then you can just case that thing out.
The wall finish itself